Let's say you and I go into business together. We decide to create a small cloud services shop. And so we are hosting VMs for multiple customers, and we decide, okay, to keep these guys separate from each other, we're going to give each one its own VLAN within our layer 2 domain. But for better or worse, business takes off. And all of a sudden we find ourselves with 4,000, 5,000 customers. And there's a big problem because we only have 4,000 VLANs to work with. And so what are we going to do there? There's a big problem with service providers hitting this limit of 4,000 VLANs. And fortunately, the industry wrapped its arms around a solution called the Virtual Extensible Local Area Network, or vxlan. And by the end of this nugget, we're going to be able to describe the purpose of vxlan and how it solves problems for us at scale in large data centers. Let's take our scenario and think about it from a traditional network perspective. So let's say we have a couple of switches here, and we're going to connect them to each other. And again, we're a service provider network, so we want VLAN segmentation for our customers. And so let's say we have a host here, maybe it's a virtual machine, a physical server, something that belongs to customer A. And then we have another server on another switch, and this also belongs to customer A. And they need to be on the same subnet from customer A's perspective. And so we're going to put them in the same VLAN. Let's say VLAN 10 on both sides. And on this trunk, we'll allow VLAN 10. And so let's say we have another customer, customer B, who has a couple of servers here. One connects to one switch, one connects to the other. Again, they belong to customer B. And in order to obtain segmentation from customer A, we're going to put these servers into a different VLAN. We'll call this VLAN 11. Now there are going to be SVIs up on the top switch for VLANs 11 and 10, which we'll denote here with dots representing the layer 3 interfaces. Oops, we better add VLAN 11 to the trunk as well. And these layer 3 interfaces are going to be part of different VRFs. And that's going to be great from a layer 3 perspective because we don't want these customers routing to each other by mistake. And we want them to be able to have duplicate IP addresses. So if we have the 10.1.1 network here on the customer A network, we'd also want customer B to be able to have 10.1.1.0/24. And so VRFs help us accomplish this, but VRFs do nothing from a layer 2 perspective to protect these customers from each other. And so that's why we still have to use VLANs. Now, as a quick note, we could use something called private VLANs to try to, not burn a VLAN per customer. But private VLANs have some limitations, and they're also very complicated. And so a lot of times we won't go down the path of private VLANs. Now, the problem, as we already mentioned in the intro, is that we only have 4,096, really 4,094 once you take out VLAN 0 and VLAN 4095, which aren't able to be used. So we have 4,094 VLANs to be able to leverage in this environment. And that means, according to our model, that really it's 4,094 customers. And that sounds great for a small business. Like, hey, if I had 4,000 customers, that'd be amazing. But think about a larger cloud provider or service provider. 4,094 is going to be extremely limiting, especially if multiple customers require multiple VLANs. Now, before we really talk about VXLAN, though, there is one other concept that we need to understand. And it's a little bit of basic networking, but stick with me here because we want to make sure we understand this. If I have VLANs 10 and 11 here on the left, and also VLANs 10 and 11 on the right, but I put a layer 3, again, the dots represent layer 3 interfaces, a layer 3 connection between these two switches, are these the same VLANs? Is it VLAN 10 on the left is the same as VLAN 10 on the right? And the answer is no, because VLANs separated by a layer 3 boundary have no relevance to one another. So why am I bringing this up? Well, because VXLAN is going to operate within a data center under the assumption that we have layer 3 connections between our switches. Because the first step to creating multiple layer 2 domains is to isolate them by the layer 3 connectivity. And so remember in ACI, for example, we actually have layer 3 connections. This fabric network right here is all layer 3. So we could throw layer 3 dots, again, keeping in mind that that represents layer 3 interfaces, on all of those connections. Which means that VLAN 10 on any leaf switch is going to be different from a VLAN 10 on any other leaf switch. Except unless we connect those using a tunneling protocol. And that is what VXLAN is. VXLAN is an encapsulation method that allows us to send layer 2 traffic across layer 3 segmentations. So let's say we have a server here on the VLAN 10 connection, and it's going to send a packet to a server that's over on the right. Well, normally we wouldn't be able to send that across a layer 3 segment. But in this case, we can encapsulate it in VXLAN. And so we take the original packet that has the original MAC addresses and IP addresses and everything, and we encapsulate it in a VXLAN header. And that vxlan header has a destination IP address that is different than the original IP address. This switch on the left is going to take it from what we call a vxlan tunneling endpoint interface, or VTEP, which is also layer 3, by the way. And it's simply going to send that packet layer 3 over to the second switch on the right, destined for another VTEP. Now that switch on the right is going to strip off the vxlan header, and now look what it has. It has the original layer 2 frame that the server on the left had originally sent to the server on the right. And so it can just look up the MAC address and send it down to the appropriate destination. So what vxlan accomplishes for us is it turns every switch into its own layer 2 domain, which means every switch now gets 4094 VLANs. So 4094 on the left, 4094 on the right. And as we scale that out throughout our whole data center, vxlan has not 4094 options, we have 16 million because it's a 24-bit address. Whereas traditional VLANs have 12 bits. So we go from 4094 VLANs to 16 million VXLANs. Scaling is no longer a problem inside our data centers. VXLAN leverages those layer 3 segmentations to allow us to turn every leaf switch in an environment into its own layer 2 domain, giving us 4094 VLANs per switch. Keeping in mind that VXLAN itself has a 24-bit address, so that's 16 million, really over 16 million VXLANs that we can use in a single data center. I hope this has been informative for you, and I'd like to thank you for viewing.